Good evening all. I welcome you all for the second session of Atal sponsored FTP on IoT, Internet of Things. I would call upon Kirtana to introduce about today's guest.
Thank you, sir. Our speaker for the day, Mr. Vivek Vasan, is a highly motivated, engaged, and a passionate engineer. He has been obsessed with the idea of using software to solve practical problems. Software engineering is a never ending puzzle that he passionately engaged in solving. He believes in the power of programming to transform and improve the lives of people around the world. He is an experienced senior software engineer with a demonstrated history of working in the field of IoT and automobile shared with development. He is skilled in Python, C, C++, Raspberry Pi, and augmented reality. His strong engineering professional with a Bachelor of Technology focused in electronics and communication engineering is from SRM University. He has completed a CCE certification on product prototyping in IoT and machine learning at the prestigious Indian Institute of Science, Bangalore. And he has completed various industry certifications in the field of IoT. He has worn many hats in his career. He is a programmer, researcher, and a tech lead at his current designation. As a result, he has a unique ability to manage multidisciplinary projects and to navigate complex challenges. He has been developing products in the AR and IoT space. He is specialist in IoT analytics, skill development, creative thinking, and problem solving. It's our honor to have him here.
Hello everyone, so my name is Vivek Vasan and I currently work as a senior software engineer with Bosch Global Software Technologies Private Limited. So a few lines about my career and my past experiences in the industry. So I started off at Nokia Networks and Solutions. There I spent a couple of years there developing and testing 5G networks and IoT solutions which work on 5G. And we had a great opportunity to work with different technologies like augmented reality, Internet of Things, machine learning, AI, in bringing prototypical solutions back to industry grade products. And now I'm currently working as a senior software engineer in Bosch. Here, I deal with predominantly automotives, that means vehicles. So I work for the braking department, and in that, say, how do I contribute to the IoT ecosphere? Is like we send data from the brake systems to the cloud, and we analyze different subsets of information so that it can make meaningful information to the driver. So saying that, I can say that I have conducted many workshops previously as part of my journey in the industries. And I can say that these workshops helped me realize my purpose of spreading knowledge to others. And it helped me see and believe the position of myself as an educator that today I provide workshops and consultancies to businesses of small scale. So I also used to listen speeches from various people and always thought, what could I learn from their experiences? And I know you're in the same place. And still, if I would sharply open, I would say take passion, take patience, perseverance from this workshop and add it to your own, because I already see a lot of faculties and a lot of other people in the position of authority in these institutions. So I'm confident that I'll hear your stories of excellence and resilience soon in implementing projects. So thank you so much for attending this event today, the organizing committee, for the invite and allowing me to share my knowledge and experience with you. So with this, I'll go ahead with the agenda of today's workshop. So we'll go through a brief introduction about the history of IoT, what is the Internet of Things, examples of Internet of Things, how it works, how it helps in this pretty good industrial use cases which you can connect to, security challenges, the pros and cons of using IoT, and what you have to keep in mind when you're in the business of IoT. So I already understand there was a previous workshop on IoT, so I do not want to bore you on the basis of IoT, but I would like to run through it so that we don't miss in key details here. So quickly on the history of IoT, the concept of network of smart devices was discussed early in the 1982. So at Carnegie Mellon, there was a modified Coke machine. So it was connected to the internet and it was able to report its inventory and how cold was the drinks and all those things. So the phrase Internet of Things was started by Kevin in his paper presentation at Procter and Gamble in 1999. So what does IoT of Internet of Things mean? So what it really means, so there's no one single definition of what Internet of Things mean, but the the definition which we go around in day-to-day life is something like this. It is an ecosystem of connected physical objects that are accessible through the internet. It can be anything. So your phone without internet cannot speak to anything, whether it can be servers to other people or without network and internet. So not, it cannot communicate with the outside world. It's just a physical object, and we call it object without internet of things. But once it's connected to the internet or through any gateway which can connect to different objects and different ecosystems, then we could say that that particular object or a thing is an IoT enabled device. So the network of things is nothing but it's embedded with sensors where it connections through the network, and it'll enable objects to collect, exchange, analyze, and identify through embedded computing systems a lot of data and system information. So let's go ahead with the definition and characteristic of Internet of Things. So Internet of Things is a network of physical objects, example devices, cars, buildings, other items, embedded with electronic software sensors, network connectivity that enables the object to collect and exchange data. So the key characteristic of things I would say is providing IP interface. So what does that mean? So if you have a thing, let's say for example, an mobile phone, you have to name it. So instead of rather when you bring it under the umbrella of Internet of Things, rather naming a phone as iPhone or Android phone, we give it a name. So the name is like a MAC address. So you give it a IP interface. So you'd say it's 192.168.0.1. So that's providing an IP interface to it. Then you connect it to the inter or intranet. It is not necessary that you need to always transmit data to the cloud, but between devices across your floor or within the ecosystem, you can connect it. So it's inter or intranet. Then fulfilling a specific function. So it's not allowing you take a thing and plug it into a network, give it an IP interface, but doing so, what specific function are you giving to that particular thing to perform XYZ action or collect XYZ information is what gives the characteristic to that particular thing. Then the last one is autonomous communication. So without any user interaction, it should happen and it should automate data transfer, connections, analyzing, and etc. So certain use cases of such type of IoT ecosystems is mainly it's in all spheres of life. For example, let's take energy sector. You have smart grid solutions. That means you can start monitoring the power efficiency in each sector in your city. You have smart metering, which is almost popular in all metro cities right now. So there's no one person who comes and physically collects the meter reading at your house anymore. It's wirelessly transmitted over the grid. Then second thing is distributed energy. So you have a very big city and a village nearby. So when the city starts, the consumption goes down during the day. You can send those power or you can distribute the energy with data to other neighboring villages or neighboring cities. So that's how energy sector comes into play. And industries, for example, it has different types of health monitoring. So what do you mean by health monitoring? Suppose I have my computer today or you have your phone today. So monitoring the health of the device, for example, the battery, how how efficient it is, what is the battery status, where it is, the location of it. So that the asset's health is being monitored in these use cases. And you have integrated operations. So what do you mean by integrated operations? You have various machines doing XYZ operations in a factory flow, and communicating and understanding what operations is being performed in the industry through IoT can be possible. And definitely production. So for example, instead of sitting and counting the number of parts produced in industry, you can think about uh, putting a data or a sensor to collect how many parts has been manufactured in an industry. Coming to logistics, the same thing, supply chain management, understanding about where the product is sitting in the warehouse, and warehouse management is one key in logistics area. Coming to medical, critical assets like, for example, blood sample collection and tracking. So a blood sample, once it's taken from a patient, should be analyzed within 6 hours. So suppose if that is not happening within 6 hours, then this can be done wirelessly and monitored. If it is falling under the umbrella of Internet of Things, and we are able to track when it came in and when it is being reported or tested. And you have patients health monitoring. So nowadays you have smart watches, smart peripherals on our body which can monitor health continuously. So this is where your things behave smartly and it reports information. So we will dive deep into all these particular use cases later on. So the last sector is agriculture. So we have this pest control. So understanding the data of your crop cycle or the damage of your crops in over seasons, you can implement pest control measures in a particular farm. Herd management, for example, you have tags in cows or your animals in your farm. You can track where your assets are moving in and around your agricultural field. And air and soil temperature monitoring for understanding how much change during weather cycles and different seasons affects your soil and which is a good crop harvest for that particular thing. So internet of things is diverse and it is in each and every sector in day-to-day life. Let's take few examples how it started. So let's say United Parcel Service has been using sensor data to save money, to improve efficiency, lessen its environmental impact. So how it uses sensor technologies is it monitors its speed, miles, mileage, number of stops, and engine health. So depending upon this, using data, they have made a new approach that's saying that only right-hand driving is more uh, miles friendly. That means miles per gallon is much more better because every time on a signal you have a free ride in the US. So that's how they have implemented this type of strategy through data. That's only possible through the data. The second thing is city offers smart parking meters, smart bus stops. So what do you mean by smart bus stops? For example, you're waiting for a bus. If it is not not connected over the internet, a person can wait in a stop thinking the bus will come, but actually the bus may have run into technical problems and the bus would have been cancelled. So having such type of smart solutions not alone enables the future but also gives comfort to the people around you. And the third one is magic band. For example, been to Disney World of late, and here, for example, you have a band connected to you. You load some money, it tracks where are you, it helps you in navigation, etc. It is wearable and it's sensor laden. That means it can give you passes, gate passes to different areas of entry. You can pay through your smartwatch or magic band, what it is called. So these are the few examples I would say which is in daily life, which is giving a very small impact, but it has much more happening in the back end. This is what I wanted to highlight to this slide. Now let's look at few examples of IoT. So for example, where all IoT is used. So we have cell phones, coffee makers, washing machines, lamps, and almost everything in today's day-to-day household, including the keys from to repairing anything in your house has some type of IoT embedded in sensor or a system involved which tracks and monitors and analyzes the data. So how does IoT work in a very, very operational basis? So IoT is nothing but it's a transformational force that helps company improve performance through IoT analytics and IoT security to deliver better results. So in terms of businesses, you see oil and gas, insurance, manufacturing, transportation, infrastructure, retail sectors can reap the benefits of IoT by making more informed decisions through the torrent of interactional and transactional data at their disposal. Like for example, let's take one solid use case here. So smart connected things allow new services. So how do you say this? So for example, my target is to mow the lawn. So in olden days, what happens? You use a blade, you fix a particular time on a Sunday, then you go cut the grass. So this is a time-based schedule. You need to perform XYZ actions. So for example, the thing here is a blade which cuts the grass. Now, how you can do it with hardware and software? So now what you have to do, just make sure the blade is enclosed in a solid movable platform, and you write software that okay, in intervals of a week, you have to cut the grass at 3 centimeters above from the ground. So a thing is mentioned here, hardware is mentioned here, and we have software. So this three combined will result into a thing-based function that is a smart lawnmower. And top of that, we can write this hard coded into the machine. But how do you provide software as a service? So here you can control that okay, this week I do not want it because it's not grown, or it's summertime, it does not grow much, so it's better to have it at 4 centimeters rather than 3 centimeters to avoid cooling. So this can be controlled by the user by having app interfaces. So that's where IT based service comes into a picture. And for example, other examples are like, for example, charging EVs with electricity. So knowing where's the EV station, knowing how much is your battery at the vehicle. So example, you parked your vehicle in the morning and you forgot what is the charge level. You can just open your app, dial into your particular vehicle, and then you can read in battery data, for example. And you can find charging stations along the route. This is all possible through smart connected things. And it's always not about providing a use case or providing end-to-end solutions, but I would say that Internet of Things or providing a gateway to Internet of Things involve in making an asset accessible to the external world. For example, you have legacy machines from industries. You have a CRO. Let's say we have a CRO in every labs. It is there. So it is nowhere connected to an Ethernet cable. Neither you are able to visualize these type of measurements in your laptop. But now you have to provide. So the task here is to make it a thing which has internet. It's an enabled thing. It's by providing it a gateway. So sending the data to the cloud, visualizing it, or finding an interface which makes a non-visualizable data into a visualized data. So this is can be possible by using Ethernet, intranet, creating rewriting software algorithms, how to push it through a gateway, and giving it an IP so that we understand what type of device this is. So this is one classic example as well. So why do we need this? So every 3 to 7 years, organizations tend to reinvent themselves, check their market scope. So according to the consulting group's report, almost 500 companies, top 500 companies from 50 years ago, only 19 of them are still existing. That's because they don't reinvent themselves. And those who do, they always use the ripples of technology, they stand on it, bank on it, and then they invent. So coming to ripples of technology, what does this mean? So there are four components of IoT. The first one is sensors and actuators. So for example, you have digital sensors, temperature, humidity, pressure, and gas sensor, for example. Then you have the connectivity layer, that means fixed or wireless via internet through LAN or through Wi-Fi. Then you have this middleware, IoT middleware layer. This is a platform where a lot of devices can be connected using different protocols like MQTT, protocols and different other protocols. It's available nowadays. So it's connecting to the middleware so that you can connect from sensors using a connectivity layer to the IoT middleware. It stores, processes, actuates in this layer. Then you have this application and analytics layer. It can be either in your cloud or it can be either in your mobile phone or in your laptop. It's where you take the data, you visualize, you understand, then you manipulate and you send it back to your actuator, your sensor. So let's look at how many devices are connected or how many connected devices you have. So we have a phone, we have a tablet, our watches are connected, we have some medical equipment which is connected, which gives you visualizations, and you have your Alexa and smart lights. So looking at this, you can say already we are living in today's world in a connected ecosystem. So that doesn't mean that, okay, it's fine, I'm connecting to the internet, but what's the use of it? So what does it actually mean of having connected devices? Like, for example, um, a minute. Um, Sorry, there's a small technical issue at my end. A minute. Yeah, sorry. So here, what does it mean by having connected devices at home? So for example, now you have a particular watch or a digital weighing scale. So depending upon this, you can understand that, okay, your weight is 50 kilos at the start of the year, and during the end of the year, due to XYZ parameters, you increase in weight. So that can go up to 60 kilos. Now, for example, you need to analyze why my weight has increased throughout the year and what is the cycle of this increase. So how do we do this? We can do this through IoT. Like, for example, it can monitor your heart rate, your sugar levels, and you're continuously increasing the weight over the year, and it can give you a statistic saying that due to less exercise in this particular month and for this calorie intake, your weight has increased by 6 kilos in a particular month, and it's staying average in this particular month. So these types of insights is possible through having connected devices. And what is this reason? So the COVID-19 is a wake-up call for the huge boom in the IoT sector. So an IoT sector has gone from a ripple to tsunami, I would say. That's because we have changed the way how we have done things. For example, we go to movies to see a movie theater to see movies, but now it's always on your cell phone. You have music through tape recorders before, but now we have Spotify, Amazon Music, and stuff. And you have again movies through DVD players, through discs you used to see, but now it's all available over OTT. So who has taken it? It's nothing but IoT has taken everything. So it's not one particular platform which we have integrated. It's multiple subset of things which we have put in and connected things. So it's nothing but connected. Internet of Things is nothing but connecting things. So for example, this particular diagram, what it says here is a phone can either call, give you notifications, send messages, view, take pictures, listen to music over the cloud, and control things as well. So this is what has happened. How this is how IoT has transformationalized the whole ecosphere. And now we come to the era of industrial revolution. Now, so where are we in industrial revolution? So we have this indexes of 1 to 4. Currently, we are in the intelligence industrial revolution. So let's see how it has transformed over the period of years. So in before 1784, everything was mechanized. There was nothing um, connected or something like that. Everything was pure handwork. And in the 1870s, then started mass production. So we had some form of assembly line, electrical energies. So we used that. We automated things a little bit, and that's when we started. The industrial revolution started, I would say. So from industry 2.0, we moved to industry 3.0 in 1969, where automation, computers, electronics, transistors, everything came into picture. And today we are in the cyber physical system. That means we have Internet of Things, we have networks which communicate to each other seamlessly without user interaction. So that's where we are standing today in Industry 4.0. And technologies and advancements has come up. So you have enabling technologies, like for example, augmented reality 20 years was not there before. So artificial intelligence, big data, cyber security is one hot topic running on Internet of Things. How do you secure data from the rest of the different OSI layers? And then you have simulation, automotive, autonomous robots, and cloud computing, etc. So now we'll just look into which industrial revolution we are, and we can think about possible scope in where we can implement IoT. For example, education. There are different universities around the world, but there are few uh, places where still we are in 1.0. That means textbook, class, blackboard, chalk piece, where we start drawing things, explaining things and stuff. And then we had this interactive visual aid which came into the industry 2.0 era, and certain schools are there. And now currently I think a few colleges are in the 3.0, where you use your phone, ipad, and your classroom experience. But in the future, which we are slowly moving towards, but we are not yet there. So we are still in the 3.0 era in the education sector, but in the 4.0, where we use augmented reality. So you have different QR codes pasted around different labs, different classes. People scan. They have augmented reality based explanation of things and how things work. So this is where we stand today in the education sector. And the next one is the shopping experience. Now, for example, yeah, still we are in cash. In most of the countries, only cash works, and you don't have any form of receipts or digital counters which tell you how much is your balance. Still, it works on pen and paper and mathematical mind-based calculation. And the second thing, you have cash registers at many countries, and now we are predominantly in the third and fourth eras in certain countries. So the third one, POS machines and swiping through cards, and fourth one is the current era, where we have everything seamlessly over the Wi-Fi wireless chips, tag, UPI, and all those things come under 4.0. So all these things is why I'm explaining all these things is these are the potential um, places where you can invent and start solving problems to bring faster acceleration towards industry 4.0. It's not always you think about industries. You have different areas and sectors where you can automate, and bringing Internet of Things as a potential candidate to replace the current process. So let's see, where are we now and what all areas and skill set you need uh, to achieve Internet of Things understanding and implementation. So Internet of Things is not alone computer science based. It has diverse fields where you can say from uh, databases, computer engineering, cloud computing, analytics, big data specializations back into mechatronics, mechanical engineering, hardware engineering, and embedded systems as well. So it is a very diverse field where Internet of Things can be applied, and we need people. So when we talk about skill sets, there comes the questions of jobs. So I always see a lot of people in the industry saying that, okay, if we automate XYZ things, will it replace our jobs in the future? So this is a very common question which has been asked in the industry, but let's see few statistics whether it can be done or not. So according to the Boston study, it says that for an engineer, the automation which can replace us is very quite unlikely. That means 13% can be done. That means in a very niche sector, it can replace human beings, and robots, Internet of Things enabled devices can take over, but it's very unlikely. Secondly, medical practitioners, it's 2%. So it's highly unlikely that such type of development can replace their profession. And a construction worker, it's hardly, it says 80%, because for example, let's say you have NASA building a space colony in Mars. So that's possible through 3D printing technologies without any human interaction. So building houses of the future is not necessarily needed by human beings, rather than it can be automated by machines and things itself. So now we should understand why IoT is an inflection point. So what is inflection point and what are the factors affecting it? So Metcalfe's law states that the value of telecommunication network is proportional to the square of the number of connected devices in the system. So what does that mean? So for example, let's say you have a TV at home, and you um, the value of watching television is directly proportional to the number of people watching television. Otherwise, there would not be any sponsors who would sponsor um, uh, TV serials, etc. The second thing is Moore's law. So every 2 years, the number of transistor on microchips doubles, and the cost of the computer also significantly decreases. So this is what we are seeing over the decades. In 1990s, to buy a computer was very costly. Only the rich could afford it. But now, if you see the number of transistors from 1990 has drastically increased. Millions of transistors have been embedded into today's phones, rather than hundreds and thousands in 1990s. And now the price of the system or an object or a product has drastically decreased over the years. So it's affordable. It's very affordable. The third thing, software development. Before, software development was a myth. It was very hard, very inaccessible. But nowadays, even a small kid can write software. So it's very viable and faster. Second thing, availability of networks. So we still have not have so we have not achieved 100% connectivity. This is also one potential area where you can improve. We have a business use case here coming down later on in the slides. So connectivity is one solution which has fuel the transition to Internet of Things becoming a big inflection point at this particular stage. And the second, hardware is nowadays more accessible, smaller, and cheaper. So let's look at a small trend, how it has been gone. So this is a graph from 2014, a study from 2014, and you can already see in this graph here that you have Raspberry Pi Bluetooth 4.0. So in 2014, you see that the inflection point in 5 to 10 years. So 2019 they predicted that there would be an inflection point of these particular devices, and that's true. A Raspberry Pi in 2019, 2020, 2021, during the the pandemic, everyone had access to this. Everyone was inventing in the space. Everyone was trying something at home, DIY things and stuff. So the graph what was shown here makes sense. 5 to 6 years before or 10 years before, and now what we have seen is we are almost reaching this plateau. So here, what happens in the plateau is you have all unwanted. So you get to understand the realization of such type of products. Like for example, Raspberry Pi is no more longer feasible. So here, everything was feasible during this particular peak here. But nowadays, you understand that okay, we need much more dedicated hardware to achieve XYZ results on a given platform. And here we go into platform of productivity. So commercial telematics, wireless healthcare, asset management is something which has already been stabilized over these particular years. Um, and looking at the trends from IoT and Industrial Revolution 4.0 in 2014, if you see, it has picked up. And over the years until April of 2022, we have significant improvement in IoT, since of consumption of IoT based products has been increased, and the R&D on these areas also has been pretty significant. And industrial IR 4.0, if you see over the years, we have peaks and bounces because we introduced video haptic based learning in educational systems, but there was a drop because there was no productive results coming out of it. And again, you see a boom in it during the corona pandemic, and after that, once it subsided, you can see the decrease as well in the use of such type of products. So the first thing is why you need access to connected devices. So let's take a use case here, and we can go about it. So for example, let's take a fruit basket. We need typically monitoring every day. So I need to maintain the quality of my goods. I need to know this information. So who's the intruder in my house? I need to know this information. How can I reduce electricity cost? What is my next bus? Where can I park? Am I healthy? All these questions was answered during the pandemic, I would say. So people started questioning these things because quality of life, way of life was something in scope at that point of time. So now um, all these things are questions, and how do we answer these? Like, for example, how do I maintain the quality of my goods? So I need a sensor, biosensor, which can sit and analyze in the fridge what is the quality of my food products. Video based analytics can understand what is who's the intruder in the coming to my home, or when I'm not there, who can open the door for parcel deliveries. And I need I need to know first, I need to gather information from the grid that okay, XYZ instruments in my house is consuming more data, and I need to reduce it. Now how can I do this? So these things can be achieved by IoT, so smart ways of doing things. So so understanding all these things, then only you can understand where's the business really lies in. So so mainly when you come to a business use case, you have to answer all these whys, and finally how to do it. So which feature the customer wants. Now for example, the previous slide we have who's the intruder, that can be a feature. So which feature do you want, and where, and how long are the customers going to use it? So is it where it is going to be used? Is it's going to be used in an industry, or is it going to be at a home, and how long it's going to be running, and all those things is one key factor where you design your IoT device. How frequently you're using it is the second question, and why do you use it? You have to understand the background of why. Then only you can go into the customer use case of developing an IoT based product. And how are you going to use it? How the customer is going to use it? Whether it's going to be just a device sitting there, or he's going to interact with it with a mobile phone. Um, yeah. So coming to the four phases of IoT maturity, I would say that we are in the monitor. First, we monitor, then we control, then we optimize, then we or automate the process. First, like let's say, for example, I want to understand uh, the quality of my vegetables in my fridge. So first, I should monitor XYZ parameters. For example, humidity inside the fridge. What is the water content inside the fridge? Any odor? Does enough oxygen, carbon dioxide is present in the fridge, the mixture of air? So first I need to monitor all these parameters. Second, I need to control. How do I control? I can control the temperature of the fridge. I can control the inlet outlet valves of air and different gases going to the fridge, which can keep the fresh foods fresh. So you have to have actuation mechanisms. Like for example, to control valves, you need a small motor or actuators, or solenoids which can control XYZ things. Or opening and closing of the door can also be controlled by different types of motors. So that's as control. Optimize. Now, for example, if you, what does optimize mean? So, for example, you have a system where it says that okay, during 8 to 9 is when it becomes too cold in the fridge and it spoils the produce. So you need to take different types of decisions during that point of time. You have to override the standard learning algorithm and say that okay, at this point of time, I do not need my cooling feature on, and you have to change it. That's where the user comes into play, where you can optimize the code or you can optimize the control mechanism which has been developed by the system. And the third name and the fourth is automation or autonomous. We'll have a different use case in the later on slides, but now here in this use case, automation is nothing but now from 8 to 9, you understand that there's irregularity in the learning algorithm, and now you learn the subset, and then you automate this in the future. That during the cold months, 8 to 9, you can turn off the fridge because it's already cold, or during the nights you can turn it off, saves power. And during the summer, it's vice versa. You turn it on for a much longer time and you do not turn it off. So this is the four phases of IoT maturity which we need to know. And we'll take one more use case, for example, monitoring. So since I've come from an automotive domain, what do you mean by monitoring? So we have vehicle tracking, like where it is, GPS monitoring. We monitor different parameters in the vehicle, for example, gas emission, what is the quality of your engine life, when is your next repair, what is the service life of your tires, what is your cranking efficiency, speed, how high is your car, whether it has been modified, whether it's been tuned. All these parameters can be monitored in your car. The second thing is control. One such thing is you have security lock immobilizer, where if you see an intruder in your car, apart, so if you don't have your key in your pocket and you go open your own car, it does not allow you. So you need to bring the car key near the car to enable seamless access to your vehicle. So such type of things, you can control your vehicle through devices which give you a access or a gateway to control another device. So that's how control comes into picture in an automotive domain. The third thing is optimize. How do you optimize? So you can calculate you're using your GPS coordinates. So in GPS, you know that XYZ street has worse traffic, and you can optimize the route like how Google Maps does it. Then you can save fuel depending upon different drive patterns. Suppose if you have three people using your car, for example, you, your mom, your sister, and you see that different driving behavior. So according to the user of the vehicle, you can optimize how your drivetrain works, or your efficiency of your vehicle through controlling the switch settings of your AC, your power delivery to your powertrain, example, all those things. So you optimize it according to the user. This is very keen in Internet of Things. Without optimization, you're not giving that extra level of feature to the of comfort to the user. So this is very keen in IoT. And the third thing is autonomous. So why is autonomous very hot topic in every sector, I would say? Because let's take a user use case. Now you have a very smart controlled vehicle. You have IoT data. Let's say it can connect to your phone. You can see your vehicle health, XYZ information, and you can see your vehicle, whether it is in back of you or front of you, analyze it during drive time. The important thing is that can it control on its own? Or for example, a car is in front of you, you're going to crash. Can it take evasive actions depending upon the sensors or actuators available in the car and avoid the crash? So that's where autonomous driving comes into picture, or self-cruising or self-safe sailing. That means leaving the steering how a Tesla is, and just the car drives on its own. So autonomous is one particular feature which is very important thing in IoT, I would say, where it gives you control. So you give the device the control rather the user the control. So giving it back to the user to avoid or to enable seamless experience is one major feature, I would say, in building an IoT system. So one question for the audience, since I've been speaking for a long time, maybe we'll ask the audience in this session. So survival test is nothing but the question is, will IoT or displace Ola Uber. So is Ola Uber a disruptive model or not? For example, Ola Uber is running into a lot of problems. Let's say you have the different taxi apps fighting against each other about ride sharing, about carpooling in the city, and you have other physical reasons where you have people not trusting a driver who drives the cab. So taking this into account, uh, would you say that Ola Uber is disruptive using IoT, keeping IoT in perspective? You can drop your answers in the chat box and let's see. Okay, so uh, the answer is definitely yes, but how do you do that? So for example, we have driverless taxi. This solves a problem. So driverless taxi is very near. It's very close to replacing drivers. So this is where you can remove workforce and shift people and make create job losses and stuff. But in the positive way, you solve a problem. You solve a problem of creating such type of human disturbances. You avoid this. You avoid peak pricing. You avoid conflicts, and we can see a different perspective about how driverless taxis is a way forward in the future. For example, how do you do this through wireless taxi? If you can look at this car, there's a lot of modification done on the car to enable it. So these are the enablers of the IoT ecosystem. For example, in the top, you can see a radar fitted here, and you have different types of sensors, cameras. You have ultra sonic sensors. You have your image, audio, video, image. Then you have your radar, and all these things are connected to your internet as well. So it's connected to the network. It can be a network of your car, or it can be a cloud. So all these things monitor the fleet or monitor the vehicle, and it can make this vehicle, which was once drivable by a driver, autonomous, and now it's a driverless taxi. So how is this possible? And you have different stages of automation. So we have to understand which field or which sector are we focusing on to automate when it comes to um, automating things and taking it next level, using Internet of Things as an application onto the existing vehicle. For example, you have here where the taxi drivers drive the vehicle, so no assistance, nothing has been there. So it's just a vehicle of the 1960s or any low cost vehicle which does not have any type of assistance to the driver. So here, human driver monitors driving conditions. In partial automation, you can say that yeah, if you want to go and dash into a car, the car is so intelligent enough that it stops you from that. And you have driver assistance features, like for example, you're rolling on a highway using your ultrasonic sensors, or you can detect the vehicles in front of you, and you can just maintain a given speed. Suppose you set a speed of 80 kilometers per hour, you have a cruise control mode. That's driver assistance. So you're assisting the driver during long durations of transport. Then you have this automated driving system, which monitors the driving environment on behalf of you. Then, for example, Teslas, for example, you set in your location. That's almost high automation, or you can say it's level 4 and 5, where you're highly automated or you're fully automated car. So highly automation is, for example, Tesla, where you can see that you set in the destination and it drives you there. But here you need user input. Suppose if it steers out of the way of the curb, a very sharp turn, the driver has to pitch in here. But mostly it is done by the machine. So these are the levels of automations. So once we talk about automation, then it comes about how do we automate? What is the driving factor behind automation? So data. So without data, you cannot do anything in your Internet of Things world. Now it comes to this trolley question. So what happens? So for example, data-driven decisions. How do you take a decision based on such type of data? Autono, the automotive sector is very crucial, safety relevant. So for example, you have a vehicle speeding at 200 kilometer per hour. Suddenly there's a barrier. You can either crash into it, hit a young group of 6 children or hit a group of old people, uh, 5 people who are old. So what's a car's decision? So here there is no right or wrong decisions here. Or can anyone tell me whether a right or wrong decision can be done? But I think there is no right or wrong decision here. It's either then we stop the situation happening completely rather than debating on which is the best possible use case, whether saving young people or older people or straight crashing, just crash yourself and losing one life. So dying or killing is no better than anything. So you can't say that you dying or you're killing people, that one thing is better than the other. So it's a huge debate which we can't take. So data is something which can prevent the whole situation to a certain extent, and now we have to understand who generates these data. So internet of things is the base of internet of things is nothing but data. So without data you cannot do anything in the physical world. Now for example, how do we get data? So we have your mobile phone. Your mobile phone can send data as, for example, how fast you're moving, what is your heart rate, where all you're gone, what is your charging cycles, um, uh, what is your sleep routine, what is your usage time of your phone, for example. And you have a lot of other sensors, from your soil sensors, from your pets, how often they sleep, how often they want to run out, how often they want to go out for xyz reasons. And you have environmental data and stuff. So all these things are sent out by physical objects known as things. So this is the basis. So this is your basis of your data. Now having data is badly useless without answering these four questions. So first is the variety of data. So what do you mean by variety of data? Now, for example, your phones keeps on sending you whether you have moved from your house or not. So it's a yes or no question, but it keeps on sending you 24 hours 7, 365 days that yes or no, that you have entered your house, you have left your house, or you are in your house. With such type of data, you cannot derive anything. So if you look at this at a IoT based solution driven a new product or something, you cannot make sense out of this type of data. So you should know what form of data you're sending. So whether it makes sense. So you have to tell whether he's going out of his house and where he is going, so that you can understand the behavioral aspect of a person, where he is going, what he can do there, what as a service I can provide. Suppose he is going to the gym, we can tell him that okay, XYZ is your work criteria, you can start doing these workouts. If he's going to a shopping mall, we can tell him that today is crowded, or today it's rainy, that he's going to this particular place, it's crowded, no point in going there and wasting your time, you can take this alternate route and go and visit a different shopping mall. So it depends on different what type of variety of data you're looking at. Then you have to look at the versatility of the data or the uncertainty of the data. So what does this mean? Now, for example, you may be sitting inside your house, but you're sitting in your lowest floor, and because of this, your coverage or your signal connectivity is very less. So now what happens? It can give you false negatives that you have gone out of the house, and out of three data, so it pushes data to the cloud every 3 minutes, and it's 3 minutes, two times it says wrong data, and only one data set is true, that you're sitting inside the house, but other two times it says you're out of the house. So here the uncertainty of the data is very high. It's almost 75% of the time it says that you're out of the house, which is false. So you have to understand the data coming from your sensor, whether it makes sense, whether it is valid, and does it apply for your business use case or not. Now, for example, of 75% of false data positives, I cannot use this in automation of a vehicle, but 75% of using it for a leisure activity is quite okay. So you have to understand uh, when is your uncertainty of your data used, whether it's in a functional safety world or it's in a non-functional safety world. The second thing is your velocity of your data. So now, when we talk about the velocity of the data coming in, you have to understand how fast it is coming, and when like the, and how and what intervals these data comes in. So what volume are you getting? Only 3 bytes of data, or you're getting 1 GB of data, 1 TB of data for processing? So this is something which we need to analyze and understand about velocity. And the second is volume and the scale of data. So are you able to get such type of volume, whether your physical device of computation is able to handle such type of data or not? So when you understand these things, then you can understand the value created by making sense of these data. Now, for example, let's take a tree, a pyramid kind of a structure. So the topmost structure is is more important than bottommost. Now, for example, data coming out from a mobile. Okay, we'll go step by step, then we'll take a use case. So data means symbols. It can be yes, no, logical symbol, Boolean signal, continuous signals, whether your temperature goes from 0 to 24 degrees and comes back to 0. This, then you have to know information. Who, what, where, and when should be answered. Who uses this? What uses it? Where it is used, and when it is used. And then you have to know the knowledge about the data. How? Like, what are you doing? Whether you're charging a vehicle, whether you're oversteering a vehicle or something like that way, how is this data coming from? And then you have to understand, why is this data coming from? So what is the use of having this data? Then using this data, then you can calculate on wisdom. Then you can take actions. So now let's take a use case. For example, you have here a smart parking solution. So for example, whether we can park or no comes in symbols from your sensor data, say 0 or 1. That means you have your smart parking facility is either empty or full. So information from this: who who parks at this parking spot, what kind of vehicle can fit, whether it's a SUV, a small vehicle, or a big vehicle, and where. Is it an empty parking lot, or you can park it empty or a full parking lot? So it doesn't make sense where you cannot temper parking in a full parking lot. And when, so you have to understand when is the peak period of parking. This comes from your parking data from these sensors. And having all these, when your answers is who, what, where, and when, comes your knowledge. So how to implement tired charging? So depending upon information, who's parking, what kind of vehicle is parking, why they are parking, then you can say, okay, they are coming just for charging the vehicle, or they're coming here just to park. And then you can also find out whether any vehicles is parking for a much more long period of time. Like let's say maximum parking duration is 8 hours, but they park for 24 hours. So you can understand this. And the organization who's running a smart parking system can also understand the utilization, whether such type of models work, or whether he's running in a loss making business. So this can be done, and from here you cannot make any such type of. So in this particular use case, there's nothing called wisdom. That means you cannot derive anything or actuate anything based on this particular data. So this is where you need to know all these questions before implementing an IoT solution. So coming back into, okay, so yeah, so we're talking about different types of data, and now it is not alone one set of data from one particular source. So it can be from different devices, which you can make sense of the data. That's called blending of data. So for example, let's take you have a home, you have e-waste, you have health, transport, and office. Let's say you take your heart rate sensor. Oh, sorry, there's a mic issue at my end. Okay, yeah, so here you have different types of um, data from different sources, and you can monitor, for example, how is your heart rate at home, how's your heart rate at in hospital, transport, when you're traveling, or when you're at an office. And with these data, you can take different data sets and analyze how you behave in different types of situations. So this is one. So this is one type of way how you can access your data. So for example, let's look into an architecture point of view, and then we'll dive deep into a technical use case, how this type of different types of data sets are used for analysis. So in this particular diagram, we have a lot of sources of data. For example, you have your keychain, you have your electricity bulb, you have your washrooms, your uh, headphones, different toys, different instruments, and your electricity source. So these datas can transmit information to your cloud, and it can perform analytical and computational uh, uh, processes over the cloud, and it can send back data to the devices. For example, here the upper layer of the architecture is where cyclic nature of measure, decide, and execute emerges. The data from the message queues is processed to create contextual information. Like for example, your data from your electricity bulb, it has rough data in that. So the data is clean, correlated, and then fed to the classifier on top. Um, it's fed to the classifier, and in the classifier, it's used for extraction of actionable information. And the user then expresses their desire and requirements. This happens explicitly by using dashboards, switches, apps, and it can happen implicitly. Like for example, it can be processed over the predefined actions by the user, and the system can also learns the usage patterns and anticipates the needs of the user. Then the desired state and the context of information are fed to the smartness component, which is over here. And the smartness component, based on these inputs of the smart devices, the smart decisions are made on what actuation is necessary, if any. Then the smartness component can be a simple feedback loop implementation or some more refined form of planning and scheduling. For example, the plan of actions created by this component can either be fed into the device or it can be processed in the cloud. Um, so this is one typical IoT architecture which we are going to look into, and the possible use cases of those are in the next slides. So first, again, we have to, once we go into the industrial use case, we have to answer the three whys. So why, where, and when. So here, the automotive industries have been around for some time and has evolved ever since. But today's cars are already connected, but this evolution is about to be changed. Like for example, here in the R&D era, the GM's diary system has evolved over the years, and it has gone to autonomous driving L4 from 2020. For example, you have Google, Audi, Daimler, Tesla, autopilot systems which can drive the vehicle without the driver itself. So it's L4 right now. So so we have one particular IoT system named as Autotoy. So what does Autotoy means? So augmented reality and ML has never been brought to coexistence for the past 15 years since the term was coined in the automotive sector. So what does this mean? So where it is used. So Autotoy can be used in engine control, transmission control, brake control, speed assist, parking assist, automatic climate change, traction control, anti-lock braking system. And it can be used for the engine components as well. So engine coolant temperature sensor, air temperature sensor, the manifold pressure sensor, massive airflow sensors, idle air controller, crankshaft sensor, cam sensor, NOx sensor, and all these things in the sense, these are things, these are features in the vehicle, and these are the sensors available in the vehicle. Now for these features to be working um, over the OBD port, we read in CAN information. So what do you mean by CAN information? So for example, you have a sensor, and this sensor communicates to a microcontroller, which in the vehicle we call as an ECU. So through these communication is through CAN network. So the network is called CAN, and we can access the information in CAN via the OBD port in the vehicle. So for example, um, uh, what does Autotoy mean at the top level? So it is an augmented reality pop-up where imminent failure in the system is noticed. For example, the driver can see a lot of red flashing lights or yellow flashing lights in the vehicle, but he does not exactly understand the imminence of the failure or the impact of the failure. This is when AR comes into picture, and it explains to the driver when he's driving that due to some XYZ reasons, example, engine transmission block failure, there's an imminent failure, and can inform the driver in an augmented way. So this is the way forward going in the future, how we want to inform the driver on different types of failures in the system. Then we can give, when the vehicle stops, we can give a green red dashboard. So what does this mean? So example, I'm a race driver. I take a passenger vehicle and I go very hard on speed bumps. I drive very rashly and stuff like that. And at the end of the ride, I will give a visual feedback via an AR augmented reality way to the driver that, okay, the drive, uh, uh, the how I handle the car during the whole drive time is way too bad. So this is when Autotoy comes into picture using different systems or sensor data. So looking at the architecture at system level, we understand that already the existing architecture, like for example, we have sensors of the vehicle, different crash sensors, ride sensors, coolant sensors, air and temperature sensors. We can use the vehicle's OBD network, which is connected to the CAN. That means the network of the car. And we can use an OBD device. So we use a microcontroller, and using this microcontroller, which is Wi-Fi enabled, we can send this data to Azure, or we can do machine learning on this and understand what type of data it is. Now, for example, let's take a prototypical use case here. I do not want to go into the tools we use in the industry, but let's say, for example, we use a Arduino microcontroller. So here it's an open source programming, and it is true that we can use even a Raspberry Pi, even an Arduino connected, if it supports OBD CAN port. We can decode information from the CAN lines. So now, for example, we use a Arduino microcontroller to write software, and it has its own Arduino hardware. We can write software to the hardware and understand or read in information from the CAN lines. And we receive data, like for example, let's say we receive sensor data like temperature, humidity, and air pollution sensor NOx sensor coming from the vehicle. And we can create a insightful dashboard like this and plot realistic data, analyze the data, and understand that during different types of ride cycles, suppose a rash driver drives, you can see the temperature of the vehicle goes up. You have the emission also going up because of too hard braking, too fast engine cranking, and all those things. So these type of data can be implied from the sensor information from the car, and we can notify the driver, okay, because of these three parameters, you are losing fuel efficiency and you're increasing environmental impact. For example, you can also use machine learning algorithms on these particular data sets to understand and derive information. For example, we can use random forest method or decision tree, we call it, for analyzing the data from the source. For example, cloud-based services like Azure and Amazon Web Services are going to be a central part of IoT development. For example, this project, it explores a potential real-world application where the automobile engine data collection and analysis is done on the cloud. All vehicles, including OBD2 diagnostics port that provides access to a wealth of internal data, can be used. For example, this project collects some of the data and sends it to Azure IoT Hub. It analyzes in Azure Stream Analytics, which is a different type of stream engine, and we use machine learning, which understands and stores the results in Azure storage. And once such analysis is early detection of maintenance issues. For example, you're driving the vehicle so harshly that it creates too much pollution and it damages your NOx sensor, or your engine has some wear and tear of your valve. So we can monitor your coolant temperature, and we can look at abnormalities of how the engine is performing in different types of temperatures. Here, the machine learning algorithm learns normal temperature behavior and then classifies out of normal conditions for richer and more accurate modeling, including month-wise information. Is it a particular month where your engine is behaving with abnormalities, or is it throughout? And allowing the system to learn seasonal changes also in the behavior. So in random forest, we allow multiple trees to grow. Like for example, let's say we have a forest. In a forest, we have a lot of trees, and each tree will take a particular data set. So it will read in the same amount of data coming from the sensor. It will process it and it will vote, or it will give a result saying that this particular driving model is bad. Now you have a whole forest, there's a lot of trees. Each and every tree will already decide the result of whether the driving condition is good or bad. And finally, a forest will then vote among the different trees and it will say whether finally it's a good or bad driving behavior. Why do we do this? So we do this firstly to ensure that you train the model in understanding whether the data which we are receiving is valid or not. So it can be that false positives can happen. So we have trained data sets saying that this type of abnormalities in temperatures can be acceptable in a vehicle. So using the trained data sets, we train the forest or the individual trees to rate and score the model, the data coming from different sensors, and then using voting mechanism among the whole forest of trees, then one particular random forest type will give you a yes or no, a pass or fail result. So this is how we use machine learning in IoT as well. Um, so for example, here you have fuel rating, how efficient or how much you can optimize it if you adjust your driving conditions. Here you can check your RPM, which is coming from your vehicle through your OBD port, and how fast you're going on a curve. So it will talk about G forces on you, and then it'll talk about your engine temperature. So all these things in augmented reality format can be put onto your HMI screen or your human machine interface screen in your vehicle. So this is one small use case of auto toy in automotive sector. And the second one, we can take Repcon, a small study project, which we did initially as one particular project where we use IoT. So here, daily transport is the last unconnected thing in the age of IoT, if you see. So as of now, only the new age vehicles in this huge industrial revolution of Internet of Things is being automated, or IoT has come into picture. So it's been in the dark ages for quite some time. So here in automotive sector, you have the huge scope of bringing IoT. So in this one box solution to the future of mobility, we give the end user endless possibilities to make the car futuristic using connectivity and syncing your heart's computer, that means ECU, to your device with security and safety. So what this particular product will do, it will seamlessly connect the user and also acts as a Wi-Fi mesh network, which gives a gateway for connected mobility. So why do we have this feature? Is because in the future vehicles talk to each other, and for vehicles to talk to each other, you have to already have a mesh network or communicating network between vehicles, which is open source. So we can already start a pilot for this and start providing this network so that it can be a gateway. So for example, a car going in front of vehicle A can say that there's a vehicle C in front of vehicle A, which is at 50 meters. So vehicle D, which is coming back of vehicle A, can already know there's a car in front of it at 50 meters going at XYZ speed, and it can take corrective actions in the future. So this is how you develop a mesh network and a gateway for connected mobility. Then you have enhanced driver guidance, which can cut driving and service costs by 35%. For example, you can monitor the different types of sensors as mentioned before, and you can inform the driver at the end of each drive cycle. That means after every ride he has taken, and you can tell him that this is the worst possible case that you can give your car for maintenance if you drive at this particular behavior, and you can improve it. You can extend your warranty or your service time by 1 year if you drive it in a much more better way. Then you can have this theft and collision detection. So theft detection is already in place, and you have this collision detection. So to customers now, for example, you can see different highways. It's a high crash zone. So here, if a car with enabled sensors already reports it via GPS, that this is it's a very crucial zone where you have high number of crashes, then the future vehicles, autonomous vehicles, can already use this data and start uh, predicting less than the allowed tolerances for a safer navigation when you have both human and autonomous driving cars in the streets. And secondly, you can use this data to enable an AR device on board. So currently you have onboard displays and you have a HMI screen, which is kind of an AR format, which is displaying data in certain cars. But yeah, this is a hassle-free way of projecting more data onto your vehicle as well. So who's going to be the end customer? So we have to analyze this as well as part of building an IoT product. So it'll be both a luxury product for both the business and the customer. So for example, it enables Wi-Fi connectivity. So even your vehicles, if it's not if one vehicle is out in a village area, so due to this mesh network, we can build our own Wi-Fi or our network within the cities and the villages, and we can provide seamless Wi-Fi connectivity to other vehicles as well. And we have this onboard vehicle health check, which gives the information to the driver directly, which is a huge benefit to the customer. Then you have this collision detection, which is a huge input to the business in terms of OEMs, in terms of Google as a map service provider, and etc. Then you have this efficient driving adaptability, which gives information to the customer that okay, he can improve the way how he drives. So this is one way of you giving value back to your both business and the customer. So in terms of customer, also telecom is in providing network towers to boost air coverage and ping in the future, where data over the internet is much more recommended, and then we get instant data on quality products. So for example, a company X is making a product of a brake system. They can monitor the number uh, of failures in the product. It can monitor the quality of the product, how long it is coming, and they can take corrective actions for designing the future products itself. Secondly, insurance companies can also use this black box information for trace claims when you have collision and theft happening. And the service sector also will be profited out of this, since using your vehicle health check, it can tell you, or it can keep parts and service ready for that particular vehicle in the future. So you can automatically book an appointment in your car and for a service of your vehicle once your health of your vehicle goes down. So these are the different ways how you approach a problem and identify who's your end customer and your target market as well. So for example, since I told about creating a Wi-Fi network, a Wi-Fi mesh, so for example, your telecom operators here is your number one target market, and for this, not only they will be providing connectivity to the product, but they will also be seeking for expanding the coverage of networks using this device. And for example, the second one is OEMs it requires huge amount of data to track the product scope and make room for development. So they need huge data of their product, whether it is working well in the field or not. So this is huge inputs to OEM. Then the number of electric and hard vehicles will increase by end of 2030. So these vehicles are our users, and we'll have to track and monitor these vehicles since it's purely going to be autonomous driving. So tracking of these data over the internet or over the cloud is must. This is where IoT also comes in as most efficient driving factor towards this particular product. Yeah, and for sure, since energy prices are going up and cutting down on fuel costs, or let's say also battery to increase battery levels depending upon driving behavior is also going to be one of the subjects of the future. So analyzing the driver data, the vehicle data, and the driver behavior is also one mandatory um, thing we have to look at in developing this particular use case for the market. And yeah, for sure reporting accidents over the map so that we map different roads with high density of collisions and accidents. Um, I'm going to skip the slide. Yeah, so coming to how a Wi-Fi mesh networks behave. So for example, you have your fleet or different vehicles. It can be cars, buses, and many more other objects around your way, including trains also. So they can be fitted with this particular product where it acts as a mesh network and connects different objects around you, and it can use this to triangulate the different positions, can exchange information seamlessly to the cloud, so it increases ping and the bandwidth of how much information can go into the cloud, and we can use this for analysis as well, and including internet sharing. So this is one way to look at it. And looking at the hardware architecture, how do we connect it? So we have different sensors in the vehicles. For example, different types of monitoring sensors for your engine pressure, temperature, what is your throttle body capacity, and then you have your NOx level sensors and your gas temperatures inside your cabin of the vehicle. So all these different sensors of your car is connected via CAN or FlexRay we call it, and this data can be accessed via a small single port in your car called as OBD. And this OBD port, if you want to start a project, you can read it in through your Raspberry Pi microcontroller using your high speed port. And if there's an accident happening, then you can, before your vehicle gets totaled, the data can be sent to the cloud and mark the position and coordinates of the vehicle. And for example, you can read in Wi-Fi signals, transmit data in and out from the device, and then you can also use this as a repeater option in the future, which is subjective but not necessarily needed in the future. Looking at the software architecture, how do we do it? So the OBD is connected to your Raspberry Pi or your Arduino microcontroller, and here you send the data using MQTT protocol, because security is something which we always look into. So we publish data to the cloud, and using this, even suppose if you want to optimize the software in the car, like how it's behaving during braking or during driving, we can give software updates via the cloud as well. So we can push data and write it over the CAN line to the engine ECU or the brake ECU. So this is one way how we can do it, and from the cloud we can do analysis on the cloud, or edge analysis also can be done, or on the board itself we can do analysis on how the drivers were behaving, and we can take corrective actions on behalf of the driver. This is where automation comes into picture. And here we have visualization as well. So since the devices are connected to the user, so using your mobile phone and your PC, you can view your data seamlessly over there. So unique features, how we differentiate this from the competitors is, so we have your OBD connected sensor. It connects all your different types of sensors in the car. You're going to give this as an augmented reality based visual feedback, and then you can see the data as well as in your mobile. So we are analyzing which type of data you need, whether you need a vehicle health monitoring data, you need your active sensor failure data, and you acknowledge that your software update has been done successfully or not. So, and also it gives you better internet connectivity in the vehicle. So all these things is which sets it apart from the way market, and which is not yet in the market as of now. So yeah, yeah, these are one possible solutions which you can do um, in the future. Yep. So the next thing, what from these two industrial use cases which we can uh, understand or decide is connecting. How do we use devices to connect it to human value? So the first thing is device connection. So how do we connect IoT devices? So enabling IoT connectivity, embedding intelligence into the particular device. So for this, we have to make sure that you have your foundation. That means there is connectivity. Your devices are able to be communicated over the network, and it has intelligence as well, or you have to build intelligence into this. The second thing, it has some type of data sensing. So like for example, a plant cannot send data, we cannot do anything, but if you have a sensor attached to a plant, then yeah, it can sense data. That air quality monitoring or soil temperature, soil moisture monitoring can be done, and this data can be captured and sent and stored as well. Then you have to communicate this data over network, intra or internet, and this should be possible. And then analyzing the data is very crucial to take corrective actions or to make sense of data. And when you make sense of the data, then it adds value to a customer or a business. And finally, when there is value to any actionable data, then comes human value, and that's when humans can take smart applications and they can infer from this. For example, if your vehicle is degrading, then you can understand, okay, because of my driving behavior, it's impacting my vehicle. So it adds tangible benefits, and you're able to control your vehicle, whether lock, on lock, checking the battery temperature, or the charge in your vehicle. And this is how you add it adds values to the human chain. So how can IoT help? So IoT has helped us reduce cost and improve efficiency, and it helps use an assets utilization and the productivity to a higher rate. And it also benefits real time using insights and analytics, because in this information era, we need insights and we need analysis on the data to make smarter decisions. Without that, it's impossible to take any decisions to make a change. And then we create more opportunities for people and businesses. So this point has been specifically told because nowadays engineers being sensitive towards automation. It not only removes jobs, it also creates opportunities for people, and we also create opportunities in exploring different types of niche areas where IoT can bring or add value to people, business, and industries. And finally, this is a new concept, IoT. It's booming in the last 2, 4, 5 years, and it includes every area of your life. So it can be health, safety, financial, planning, assisting people, maybe a robo assisting the old age people with, or a fire and rescue safety personnel, and save money for people. For example, helping them understand their vehicle more better and giving them better ride options, or ex- advising them not to drive rashly, and it can assist people for saving lives as well. So security challenges which we have to take into consideration is, we have to protect the data which we're sending over the vehicle over to the network or storing it locally, and it has compliance and privacy rules. Now, for example, if you take your watch data, which stores your name, your information, your age, your health data, so, and whether you, where you live, it tracks your GPS location. So this comes with privacy and compliance rules. So there is nowhere you can compromise on privacy, because you anyway need to know all these statistical data to take actions. But it depends upon which level of security are you using the information and then developing value to the user. Then we have a ocean of new devices, and you have a universe of integration problems. So what does that mean? You have legacy, for example, in industry, you have old machines, you have new machines. So new machines may be of a different architecture, the old machines will be of different architecture. Now to combine them to make statistics, or to understand how these two machines communicate between each other, and is going to be a struggle. So integrating a solution which can read in both devices and then infer data from that is a challenge, I would say, in today's world. And consumers and the level of perception. So to understand what the really the consumers wants and what do they need of the data, so whether it makes sense or not, is something which we as developers should understand. Then device management. So here, how much, for example, we can store and process data locally, but now it comes to device management, how much you can do that, and the volume of data stored and processed and used is a question. So we have to think about how to do software and hardware, and the management of the whole device is something which we need to look into. So the pros and cons of IoT, Internet of Things, is you have communication, automation, and control. over there on the edge, and you have information. It gives you quality information about the device you're using. It saves time, and it is efficient, and it saves cost. The problems of IoT is now compatibility between different interfaces, devices, and systems. The complexity as it goes in different industries and different machines. Then you have to deal with loss of privacy, security, and safety. So when you start reading data of any type, every industry faces this problem of privacy, security, and safety. And yeah, and to manage such type of devices, you need lesser employment, and this will displace people from their current roles. Then the technology which we are going to build, how is it going to be dependent, and how it takes control of one's person's life. So this is something is also one of the cons, I would say, when it comes to IoT. So I have 2 minutes, and the last 10 minutes we'll take it for the questions. So this will be the last slide of my presentation. So finally, what all you have to keep in mind when you're developing your Internet of Things solution is you need to check whether you connect your devices to an internet only. Is it only required that is it really needed you need to connect it to an internet, or you can just keep it in an intranet or locally connected within your system. For example, you can take different types of microcontrollers talking within your home, and it is not necessary that you need to connect to internet. You can locally connect it when you enter your home through Bluetooth, or different other screens connected to your TV, where you can press a button in your TV and then connect it or operate it. So this is one. Then you have to create a separate network for your IoT devices, Wi-Fi router, and disable guest access if needed if you're doing it at home. And it's better to keep it isolated from your everyday work product and your control access mechanism for security. Then yeah, for sure, you have to set different types of passwords, and handling passwords to manage such type of complex situations. For example, you have an industry where you have a robot controlling XYZ operations, and if it is not strong enough, or if your firewall is not strong enough, then or your car is not strong enough to do automation, then yeah, it will cause a serious safety risk here. And you have to have a universal plug and play feature as well, so that it can detect and expand the number of devices used. And yeah, you have to ensure that the latest firmware, or you can be able to update your IoT devices using internet or a different router, and it should be supportable across different updates in today's software era. And you have to be aware about cloud services, as IoT devices mostly rely on it, and also be syncing of sensitive data over cloud, for example, AWS and Microsoft Azure. You need to know which type of data you need to process on the cloud, and whether it's reliable or not. Then you have to maintain personal devices out of workplace, or do not connect it on official network if it is planned during prototyping phase at your workplace. Then you have to always be able to monitor your devices, and then you have to assign IPs so that you can identify which of your devices is connected, or which devices have been failed. And then you have to verify the information on each IoT devices has, and deny access to unauthorized new devices which is coming to your ecosystem. So these are the few tips which you have to mind when you're building IoT devices. So this is the last slide, and if anyone has questions, then you can shoot them, and we can see how best I can answer. So it depends use case to use case. So for example, when you talk about cognitive models, like how behavioral models of a person can influence your IoT decisions on a device. For example, your heart rate monitor, or looking at your stress levels from the data getting, which can be populated through your watch, which can be read in through different types of sensors. We can estimate what is your behavioral model over a period of time, when the number of uh, data sets is available and we have enough trained data. So but taking corrective actions on your cognitive more behavioral model can be quite tricky, I would say. Like, for example, depending upon your ride statistics and how aggressive are you as a driver, you cannot take drive decisions itself. Like, for example, whether you need to slow down your car or go fast, or allow the driver to do rash driving or not. So this cannot be done. So it depends situation to situation.
Vivek, I have
And
another question. Kindly
mhm.
share the IoT applications in agri field.
Yeah, sure. So agricultural field, I would say I have not so much experience in that, but from the fellow people who have been associated in the field, I would say that crop modeling and different types of crop usage, I would say, depending upon different seasonal aspects, monitoring the crop quality, depending upon how much water, the temperature, the particular crop or the particular field is getting, and controlling. So using actuators, you can control which part of your farm can get more water and which part of your farm doesn't need any water. So this can be done rather at a very let's say focused manner. So instead of having one sensor for your whole field, you can have hundreds and thousands of sensors split across hectares of land, and you can take decisions based on it.
Vivek, there is another question. Can you suggest a few databases for IoT for research purpose?
So we don't have, I mean, it would be totally wrong if I would say that there are few databases for research purposes in sense, but I would say that almost all databases available today, like for you, we have Azure database, you have AWS databases, all those things have the bandwidth and the capacity to do so. So it depends upon developer to developer which language are they okay with, how friendly the database, how is the access license, and those stuff really matter. But for example, you can use Azure's blob storage databases for your models to store data.
Sir, and also for your kind information, the participant is asking the question in terms of research oriented. Uh, this databases, they can use it for a textile industry. Okay. They can use the databases from textile industry to identify the yarn particles, dust particles. That is one of
Hmm.
the excellent device which we can monitor the dust particles in the textile field. Even many
Hmm.
textile industries in Coimbatore, they are using IoT devices.
Okay. But I think my answer would remain the same. So databases doesn't really matter. So you can keep it on your device, you can keep it on the cloud, but it is not going to change your outcome. It can be looking at atoms from your particular textile, or you can look at atoms from space. You can receive that from sensors, but storing it in databases, it's subjective, I would say. So you have free databases, you have paid databases. So IBM, they have for students free databases, so it can be used for research purposes if the policies and is read properly. So the data which you store in certain third party databases can be used by the company itself. So it depends case to case, how do you want to do it.
Vivek, I would like to ask about the barriers in implementing IoT.
So like for example, I told you the trolley problem. Like for example, you have data, you have variety of data, you're able to imply an analysis out of that, or you can take action and you can actuate something. Like for example, you have a speeding car 200 km per hour. It's either you crash into a barrier, kill 5 young children, or kill 5 old people. So now with this type of data, the barrier here is like you cannot tell which is best. So here with this type of analysis, you cannot act on it. So when you make a device to take a decision at this point of time, it's very subjective. So you can't say whether it is a right or wrong decision, because we as a driver, when we are put in that position, we cannot take it. So this is the barrier where we would say that here we cannot do further analysis and we cannot come to a conclusion. But other ways, if you see, the other barriers is privacy. So everything we need an IP interface, I would say. So you need to name it. So if I, as a person, Vivek's data is this, should be stored like that. So it violates my privacy concerns. So only these are the two possible barriers, I would say. And then it's latency and network, which is solving in the faster rate. But I would say there's none other barriers I would personally feel in IoT implementation.
Thanks, Vivek. I have another question from Govind Pandey, sir. Do IoT applications related to data rate?
I didn't get your question properly. So
Is IoT applications related with the data rate? Data rate matters anywhere in IoT's performance?
yeah, for example, it depends. Like, for example, if you take a safety critical feature, the volume of data, that means how fast you're able to communicate, and what is your volume of data you're getting to take a decisive actions. For example, if you know from your cloud that your vehicle is going at 100 kilometers per hour, it is taking a turn. Now you need so much amount of data at very fast frequency saying that you're approaching the corner. Now you need to slow down. But if you're going to get this in intervals of half an hour or 10 minutes or 1 minute, this is not going to be helpful. So application to application. So how is your data rate? Whether you need data from the cloud, whether you're sending data to the cloud, depending upon safety, whether it's passive or active, it depends. So if you're going to say that, okay, I need to know my energy cycle analysis over a year, then fine. Every month you can send the data once, that's enough, from your local storage to the cloud. And the frequency is monthly. So I would say that's okay. But when you say in a real time application where lives are involved, you need to have a better data rate, and frequency should be much, much way too higher.
Hope all the questions are being answered and your presentation was very fine. I would call upon Kirtana to deliver the word of thanks.
Yes, sir. Thank you, sir, for this brainstorming session on IoT with your valuable keynotes. Thank you, participants, for your presence throughout the session.
Thank you, organizers. Thank you, participants, for your valuable time. And if you have any further questions, you can always drop me a mail. So we can stay connected later on as well. Thank you.
Thank you, Vivek. It was a very informative session. Elaborately, you had done prepared in all the avenues in IoT, I think, based on your experience. Thank you for joining and
engaging.
Thank you, ma'am. I hope this creates value and you can able to connect it as you're doing projects and developing further. So always having an industrial background of how it is
definitely it will be
connected in the
useful
backend
for
code
the
makes meaning.
participants. Maybe in the lab sessions, this FDP is like this full week of online sessions, and the second week is offline session. Maybe they can make use of, they can practice whatever they learn in this online session in the laboratory.
Exactly.
And, it will be very useful for them.
Yeah.
Thank you for sparing your time. I think it is a different time for you, right?
Exactly. Yeah, it's 5:30 here, so.
Okay. Thanks a lot.
Thanks a lot.
Thank you.